Hi guys and girls on YouTube, and welcome to my channel. In this video we're going to be taking a look at another vintage TV. Now this particular TV brings back a lot of memories for me because the first time I repaired one of these, it was when I left my job in an electrical shop and I was starting out my career as a television engineer at the age of 20. Now this set actually dates from about 1976, so when I was getting these in for repair in 1984, they were already 8 years old then, and I remember these used to have such a good picture on them, and I quite liked ITT. In later years I actually signed up with ITT to do under guarantee repairs, and they used to send me lots and lots of service manuals for free, but this predates them times. The first time I repaired one of these had been 1984. It's just about 40 years ago, so you can see that's why I've got this TV, just for the trip down memory lane. Now I actually bought this off a lovely pair of girls. They were doing a house clearance, somebody had died, and rather than just get the house and chuck everything away like most people do, they were actually selling everything off, and that's the thing to do really, is to always try and sell something first, because then if you can't sell it, then you can chuck it away. The view I take is if you pay for something, you're going to appreciate it. But anyway, enough of that. Let's turn it round and have a look. Now I've no history on this, I've no idea when it was last used. These all seem to be free. The on and off button stuck, which won't be a problem if it's stuck in the on position. I've no idea when the last time this was ever used, or if it works or if it doesn't. So let's turn it round and take a look at the back first. Right, so that's the back of the telly. It's a model number ITT CVC20. I think this is a CVC20, but I can't remember, because there were quite a few sets that looked like this. In fact, I remember one, and it had a lot of red LEDs on the back of the chassis that all lit up when the set was running, and if you had one of the power supply rails went off, you'd have an LED out. Now I'm not sure if that is this particular set or not. I can't remember, it's a long time ago, 40 years. I do seem to remember that the triplers were a very common fault in these, and they were quite common for dry joints. But as regards spares, I don't have any parts at all for these. Having said that though, I actually had a quick look round and I found what I think is the audio output module for one of these sets. As you can see, it's plug-in boards, and I'm not even sure if you couldn't take these out and plug them in the back of the board so you could actually work on them. But what we're going to do is get the back off the telly and have a quick look inside. Also, I've had a look round, I've found the service manuals. I think it's 20, I'll know when I get the back off, but I do have all the service manuals, so we should be able to repair it, whatever model it is, whatever chassis it is. Actually, I think I'm being a bit optimistic here. I say I should be able to repair it, I might not be able to repair it, it depends on what's wrong with it. I certainly won't be able to repair it if this line transformer's faulty. But anyway, that is it up with the back off. It's not the one with the lights on, but I can see next to these modules there are holes, so I'm pretty sure that you can plug them boards on the reverse side of here. Now I need to have a really good look round with a light, but I can see things that have been done to this. I can see new soldering, and if we look on there, yeah, confirmation it's a CVC20/3, which is very handy. So I think what we'll do is undo that and lift the chassis down and just have a look around, make sure there's nothing missing out of it. Now, another odd thing that happened is when I went to Burkett's a few months ago for my birthday, I did see one of these red, green, blue output modules in Burkett's, and I think they only wanted about £2 for it, and I was in two minds. I thought, shall I get it, shall I not? And in the end I thought, no, I'd be just wasting my time buying that, because I'm never ever going to see one of these sets again. Well, look at this, I've come across one now. Right, so that is the chassis in this service position. We've still got the screening can over the line output stage. That's a good sign, and it's still clipped in, so there's a good possibility this cover has never even been off. That there is the module I've found, the sound output. I presume that's the frame. There's some parts mounted on the board. These capacitors, we'll have to check these out, because some of these look like the jackets have shrunk, so they'll definitely need testing before we switch it on. Main smoothing block, that'll need reforming. Let's have a look what tube we've got. It's an inline gun, but I can't see the brand. It's under there. It's probably, I would have thought, an RCA. But I always remember these having a good pitch on them. Even at like 8 years old they were good. So fingers crossed, this will be good. But I'm not really seeing anything that's been changed. There's nothing stands out obvious, so I wonder if it's just had dry joints done to it. That's the chopper control module down there, and the chopper transformer's actually inside this can down there. Tripler looking through there, that looks pretty original. The line output transformer there, is that a Phillips Mullard part? It looks like it is. Let's just hope that that is alright. So what we need now is the CVC20 service manual. Now, as it happens, I know exactly where they are. I'm not going to be searching for hours. So I've found the box with the service manuals in. I remember this set, the manual had a blue front. What's that? CVC 1100. That's a lot later, that. Remote control gun. So what we've got here, CVC 45, CVC 25 and 30, CVC 20-2. Now we've got 20-3. So well, what these others are down here, I can see some more. No, another 20-2. Right, well that's the only ones in this file, but I guess that one is going to be a starting point, even if it's not exactly the right one. Price £2, look back then. Now I've just had a quick look through my photographic archives, and I found a picture here of one, that's it there, a picture of one of these exact sets. Now by the late 80s nobody wanted TVs with brown cabinets, and all these here, this picture's from when I had the shop, the late 80s. All these were stacked up ready to be thrown away, because the brown, I think that's a CVC9 there. That'll be a 718, 719, is it? Later on nobody wanted the brown telly, so we were scrapping these, hundreds and hundreds of them. And what we used to do is we used to wait till we got a skip full and then hire a skip for the day and throw them all away. So they're all tellies, all waiting to be scrapped. video recorders, Betamax, all waiting to be scrapped. Right, so back to this. Let's have a quick look in the service manual. Circuit description, and the circuit diagram appears as a pull-out. Look at the size of that for a diagram. Absolutely massive, that when it's folded out. That's a tripler there. I think the parts marked in the triangle, these were safety components, and that meant that you had to fit exactly the right part supplied by ITT. Not that that's going to happen in today's day, but you'll see how clearly laid out these diagrams actually are. That's power supply there, switch mode controller TDA2640. I wonder what the HT rail is. Oh, 125 volts and 20 volts for the LT. So we could actually put a 20 volt bench power supply across there, and that will effectively reform a lot of the small electrolytic capacitors in there. Right, so what I need to do now is get the capacitor reforming, the mains reservoir down there, get some heat into this, and we'll come back to it a little later on. In fact, I think what I'll do is I'll remove the screening can and we'll take a quick look in there first. So the panel I've got has got the same numbers on as the one in the set. Sound output panel. Right, so here we go. The screening can's off now. It looks nice and clean in there. You can see a lot of blackening on the board, because sets like this, especially I find, especially with these this type of tube, they use a lot of deflection power. And they run very, very hot. The fusible resistors haven't sprung open there, so that's a good sign. What's that there? Is it the east-west module? I can't remember that. Looks like it might be. Another resistor there that's not sprung. Right, so what I'm going to do now is I'm going to stop the camera and I'm going to get the capacitor reformed and just have a really good look over this before we do anything. Right, a little bit more light on now. While the capacitor's reforming, I'm having a quick look around. I can't see any dry joints, and the reason for that is somebody has already done them. But what I have noticed, there's a strange green patch just there, if you can see it right in the middle of the screen. Now that is usually caused by an electrolytic capacitor leaking, and it's attacking the PCB. So what we need to know is what is behind there. You can see it there. So we've got 4 legs there. That is a wire wound control, and I'm interested in them 2 pins there, which is probably an electrolytic capacitor. Right, so a bit more light. You can see how black the board's gone now. So that's the wire wound control there. The capacitor I'm interested in is that blue one there. We're going to have to take that out because that will almost certainly be leaking. Not leaking as in leaking electrically, but leaking electrolyte out of its seal. So that's going to have to come out first. Right, well that's it. 220 mic 16 volt. If you look underneath, it doesn't actually appear wet now, but that leg's green where the electrolyte's been leaking from. So I'll have a look at the diagram what that is. Yeah, so it appears to be that one there. It just generates a positive or negative DC voltage for injection into the line scan coil, so we can shift the picture from left to right. So it probably would have worked without that in anyway, but we do need to change that before it causes any more damage, because the chances are if you power it up, it'll probably start leaking again, even though it's looked quite dry now. So let's get one of them in. Right, so that's the new capacitor in there. Now I think due to the amount of heat generated in these tellies, I think there's going to be lots and lots of capacitors dried out that'll need replacing if we're going to make this into a half decent set. But the aim of the video is not to do a full restoration on this, because that's going to take a long time and I've got other things to do. I'm just doing this now, waiting for spare parts delivery. But I promise these girls I'll get this set going and I'll show it on YouTube. So the aim is not to do a full restoration at the moment. As long as I can get it on and get some sort of pitch on it, I'll be happy. So while that is reforming, what I'm going to do is I'm going to search out some of the low tension rails. I'm just going to apply a polarizing voltage to the rails to effectively reform a lot of the smaller electrolytics. So let's go to the service manual. So if you look there, off the chopper transform, we've got a 20 volt rail reservoir capacitor there, safety resist, spring open resistor there. There's no reason why we can't connect a 20 volt power supply to that and just leave that for 5 or 10 minutes just to re-establish the aluminium the aluminium oxide layer on the capacitors. Also underneath, that's the main HT rail, 125 volt. There's no reason why we can't apply a voltage across there as well, and just leave that running for a bit. So that's where we are at the moment. So far we've just got C68 changed, and in the back of the manual got some handwritten notes. As you'll notice, I can't spell. I've never been able to spell, but I can see what it means. Right, so there we go. We've got 20 volt rail powered up, drawing 40 milliamps across C50. I will just leave that for 10 minutes and then we'll do the main HT reservoir capacity. Not the main HT reservoir capacity, the output rail, the 125 volt reservoir capacitor. Be that one, and I think there's one there and one there, so we'll do them next. So we're back onto the ITT again. The capacitor's been reformed. The reading across the wires for the mains indicate the on and off switch is stuck in the on position, which is a good start. Now if you remember earlier on, I said there was one of these and it had all LEDs in the back to show different power supply rails were running. Well, if you look at this space here for the LEDs, and what does it say there? LED 5, 24 volt. So that would have indicated the 24 volt was running. There's another one down there and that says LED 2, 20 volt. So it looks like this is an earlier of the CVC20s without the LEDs actually fitted. But anyway, so we're getting closer now to switching this on. I think that's about all I can do now, apart from plug it in, see what happens. Right, so I have just noticed a dry joint which I didn't see the first time. and it's in a serious place. It's on the line scan linearity coil, which means it'll burn up the parallel damping resistor if we leave that. So let's just have a look where I saw it there. Let's see if we can zoom in. Might be able to zoom in, might not. Yeah, you can see it there now. So that definitely needs doing before we turn this on. Right, so that's about all I can do now. I've just warmed it up inside with a bit of hot air, because that serves two purposes. If it's warm, components won't suffer from thermal shock when you turn it on, but also any capacitors that are slightly worn, if you warm them up, it'll increase the capacitance and lower the effective series resistance. I mean, this is only a temporary thing. Once it's cold again, if a capacitor's worn and you warm it up, it makes it better, but first thing in the morning when you turn it on, it's going to be cold. You'll still have a problem. But anyway, I think that's about it. We're in the lap of the gods now. I've got the key nectar. What I'm going to do is I'm going to switch it on here, but I'm going to set up the camera on a tripod so I can go hands-free now, just in case we have to run or anything happens. Right, let's get that in focus first. No, it doesn't want to focus. Right, there we go. Camera set up on the tripod. We've gone hands-free. So what I'll do is I'll do a quick flick first and see what happens. Here we go. 3, 2, 1. And I can hear something. Now something there didn't sound very happy. Let's just demonstrate again. Let's zoom that out, see if we got some sound. Don't know if you can hear that. And I don't think we've got any EHT. There's a possibility the tripler shorted out. So I'm just going to disconnect that first and then we'll try again. Right, so that is an absolute major disaster. The set ain't going to work now. I've desoldered it there and look what's happened. That has fallen off the line transformer. So whether we can attach a wire back onto there, I don't know. But if we can't, that's completely ruined it. But as the tripler's disconnected, we might as well just try it again, because if the tripler's shorted out, at least we'll see the line stage come into operation, the tube will light up. What a disaster that was. Right, so maybe all's not lost. I can just about see the EHT wire running under there into the winding. So we might, if it comes on now, the tripler's faulty, might still be able to recover this. Right, let's try again. 3, 2, 1. And I don't know if you can hear that, can you? It's still not coming to operation, so maybe the tripler wasn't faulty at all. There was no line stage running. CRT's heaters aren't lit. Right, it's time to make some voltage measurements now. Right, so we look at the power supply. It only supplies 2 rails, 125 volts across that capacitor there, and 20 volts across that capacitor there. Now I found I've got the 20 volts or 19 point something across that capacitor, so that's alright, but there is no voltage whatsoever across there. Now they're coming off the same chopper transformer, which means the power supply is running, which means either that's short circuit or we have a short across the HT rail, which you would have thought the power supply shut down, wouldn't you? But it's still providing this 20 volt rail, even though we've got nothing there. I mean, of course we could have just an open circuit rectifier, or we could have a dry joint here somewhere, but I'll take a look at that next. Right, so we don't have any short across this rail, but this rectifier here seems to have an unusually high resistance measured in circuit, so I think we'll take it out and do an out of circuit test. And as soon as you get it out and you can see it's a semicron one, you know this is going to be faulty. These were very, very unreliable. In fact, what was the other set that used these where they went intermittent? Bush T20, was it 718, 719? These were always giving trouble. So let's have a look. There we go, completely open circuit. Right, now I do happen to have a few of these in stock, so even though they're unreliable, we're going to put another one in. Right, let's see what happens now, because we know the power supply is running. We've got the 20 volt rail up. Here we go, 3, 2, 1. Oh, let's turn the volume down. Try again. Well, that's a good sign. We have noise. What we don't have is any EHT now, because the nipples dropped off the line transformer. I was going to say if we switch it on now, at least we'll be able to see if the line stage is running, because you should see the CRT heaters lit up, even though we've no EHT. But I've just switched it on again and it's tripping, and I'm sure I can smell something burning in the line stage, and this is one of the problems with TVs when they've not been used for a long time. You just get one problem after another. But anyway, I'll press on. Right, I'm getting this strange feeling that the line transformer's packed up. I think the best thing we're going to do is take it out and just run a test on it. Right, so that's the line transformer there. You can see the row of pins. What I've done is I've put some new solder on these first, because it makes it a lot easier to desolder. So just go. And you can see how much easier it is to solder if you put a bit of fresh solder on first. Yeah, well, confirmation, the transformer has died. We've got no output from it, or at least no output from the overwinding. So, we're in trouble now. I definitely haven't got one. Can I get one? I don't know, very unlikely, but I'll have to search on the internet. There is a part number on it. It's a Phillips part number. AT279/003041.3. So looks like we have to close the video now and put this set to one side and see if we can find a transformer from somewhere. Right, so after a delay of a couple of weeks, because I've had a lot of other things to do, we're back onto this ITT again. Now, if you remember last time, the line output transformer packed up halfway through, which with hindsight, I really should have taken this transformer out and baked it in the oven to drive out any moisture. But at the end of the day, this nipple would have still fallen off because this wire's gone very hard. You can't even bend it anymore, it's gone that hard. And all this outer coating's all gone very, very brittle. Now at this point you would have thought that's game over for this telly, but look at this. HR 2080/20 reproduced for an ITT TV. Obviously not the original, I would imagine, with a number like AT. That's probably made by Philips. But look at this. What have I got here? Just look at that. What a beauty that is. Brand spanking new in its box. Now over the years I've actually made a few different line output transformer testers, and they've all worked to a varying degree. I think this is the earliest one I made, something like 1981. But what we're going to do is we're going to cover these in another video another time. There's another one I've made, and there's one I made in mid 1980s. In fact, this has been used, if you look at the notes there, this has been used on ITT before. But what we'll do, this is a live transformer test, so I didn't actually make this, I bought this. And don't ask me what's in it, because I did look inside and it's potted inside with resin, so you're not going to be able to copy that. But what we'll do is we'll cover, I'll make a separate video one day of testing out line output transformers. But just forget all this lot for now. I'll show you a quick way of testing transformer just with an oscilloscope. Right, so for this quick test we're going to use the probe calibration output of an oscilloscope, and what we're going to do is we're going to put that in parallel with one of the transformer windings, so it actually makes the transformer ring. Now I know what you're thinking. Most people will measure the amount of times it rings and determine if it's got shorter turns from that. Well, I'm going to show you a slightly different way. So let's hook onto the calibrate output. It's a 1 kHz square wave. There we go. But the frequency I don't think is really that important, but that's what's coming out of my Tektronix scope. So we're going to connect that now in parallel with a transformer. Right, so there we go. I've connected me 1 kHz signal and the scope in parallel with one of the windings, and you can see now the transformer starting to ring. Now if you see the amplitude of that, it's right up to the top there. It's not important, but you'll see why in a minute. We're touching the top there. Now what you do is you take one shorter turn and wrap it round the limb of the transformer like that. Now if this transformer's good, when we touch these together it damps the winding, the amplitude there should fall. So I'm going to have to see if I can hold the camera at the same time. What I'm going to do is just touch these crocodiles together. Here we go. So when I touch them together like that and I open them, so if we look at the waveform there, that's with the shorter turn open circuit, and that's with the shorter turn shorter circuit. Now see how much the amplitude's dropped there from just one shorter turn. That's without the shorter turn, and that's with the shorter turn. Now if we do the same test on this transformer, we use exactly the same pins, the same setup as that, one shorter turn, you'll find, because this has already got shorter turns, an extra shorter turn won't make any difference to the amplitude of the ringing. So I'll just set that up and show you that now. Right, so I've got the old transformer with suspected shorter turn setup. I've got the same test. I've got one shorter turn around there. I've actually magnified the oscilloscope, as you can see, so we can see the effect more, but we're touching the top there. But when I take these wires here, so if you look here, I touch them together, all with great difficulty anyway, trying to hold the camera at the same time. That's better there. I can touch them together. So let's look at the scope signal now. When I touch them together, absolutely nothing happens. And the reason for that is because the transformer's already got shorter turns, so one more extra shorter turn makes no difference to the display. So that's a test you can do with just an oscilloscope for shorter turns on a flyback transformer. That actually more or less explains how these transformer testers work. Now there's one thing that has just crossed my mind, and I'm sure people will be sitting watching this video now shouting, screaming, change the tripler. It is highly possible, yes you're right, it is highly possible that a faulty tripler could have taken out the old transformer. And just to prove the point, I'm looking through these ITT technical bulletins, and there's so many references to the tripler actually killing the horizontal output transformer. There we go, no EHT, no sound division, maybe due to a faulty triplet. Damage to line output transformer can occur. If we turn over to another page here, this is for CVC20. I'm not sure, I think it has the same line transformer, and it keeps saying over and over again, when replacing the tripler, the horizontal output and transformer could be damaged. In fact, in one of these technical bulletins, it actually said that in the CVC20 the triplers were failing when the sets were still under guarantee at about 11 months old. So it's obviously they've had a lot of trouble with these triplers in the past. Now this set would still seem to have the original one in, so I think the sensible thing to do is to just hook another one in and don't even risk connecting up to this new transformer first. So one last thing to cover before we fit this transformer. You've got this small auxiliary winding here. Now if we look at the diagram here, that's the winding there, 50 volt peak to peak switch mode power supply. Now this does two jobs. It actually operates the over voltage trip by rectifying a voltage and smoothing it across that capacitor there, and it's also fed into the IC for phase control and timing. So when you fit this back, do not get these windings reversed, and that because it'll mess up all the power supply. That's why you've got a red one and a white one. One will be a start to the winding and one will be a finish. Now it's not actually marked on here, but what I've done, so I don't make a mistake, I've just wrote on the chassis, it's white to that side, red to that side when we come to refit the transformer. That is very, very important. Right, let's get it in then. Right, so that's the new transformer with the original wires fitted in the correct position. Now I have just noticed on this little board standing up here, that's the east-west modulator board. I don't know if you can see it, but there's a bit of corrosion on that potentiometer. The actual driver for the east-west modulator, the transistor that's on there. So it looks like we probably have an east-west fault as well. So that's going to need attending to, but let's just concentrate first on getting the transformer back in there and getting the set on. Right, so I've just unplugged the east-west modulator board just to give me a bit of a better access to the line transformer. Doesn't show up very well, but it is a bit corroded. But also I've desoldered these couple of caps as well. Nope, have I desoldered that? Yeah, I have desoldered it, yeah. Just take them out, and then because the extra windings there, and it's in a bit of a difficult place to get, but now with these bits out of the way, it's a lot easier to fit the transformer and get them wires in. So that's the transformer in. I've not soldered it yet, but I've just noticed something else, and this is a good reason for writing down where the colours of the wires go, because if you look down there in them two holes where the that extra winding went, they're both labelled WH, which are presumed for white. You know, you presume, you would have thought one would be WH and the other one would be RD for red, but ITT have chose to designate them both WH, so that's another good reason for writing down or even taking a picture on your camera the phasing of the wires. And what could be better in a 1970s TV set than using a roll of 1970s solder? Perfect for the job, that. Right, there we go, transformer in. As you can see, there's two, where have they gone? There's two holes there that would have been used for screwing it in, but it didn't have any screws in when I took the old one out, so I'm just going to leave that. And while them caps are out, might as well just test these as well. Right, now that one's okay, but this one is actually a bit low in value, 293, and it should be 470. So we're going to put a new one of them in. And that's it there, it's C31. It's actually frame scan feedback to the east-west modulator. That's the frame scan coils, and that's the frame scan coupling capacitor. So it just comes back. Is it that one? I thought it went to yeah, I think it's one of these here anyway, pin cushion input. Right, so let's just get that in. Yeah, it is actually that one. It's the input to the east-west modulator, so it won't cause a big trouble with it being dried up anyway. So that's one of the old caps back in and a new one. I've no doubt there's going to be loads of capacitors need changing in this, but for now I just want to get this on and see what faults we're left with. But I've just noticed here another point of concern, and this is going to be important too, because this isn't a genuine transformer, it's a pattern one made by HR. If the original one, if you look where the EHT nipple was, it came out here facing me. Now if I move that out of the way and look where this one comes out, it actually comes out there, and very, very close to it is a heatsink. So we're going to have 8 kV there and possibly ground there. So we're going to have to put some insulating material around that before we power it up. What we don't want is that arcing from there to there when we turn it on. That is a no-no. So if you just move in, you can see how close it is there. So we're going to have to put a bit of plastic around there or something before we turn it on. There, look, and that is no doubt an earth heatsink. Right, so just a temporary bit of plastic in there. I'll think what to do later. I've left the tripler disconnected. I'm going to fire it up first, and we'll know if the line stage is running, because the CRT heaters will be lit. I've just cleaned that so we can see better. But I'm just going to fire it up quickly, and then if it comes on, and the time base is running, then we can think about just dropping another EHT tripler in. Right, so here we go, we're ready to fire up. There's no plug on it, I've just got it in this connector. The switch on the telly's still stuck, I've not looked at that, so we're going to turn it on and off here. 3, 2, 1, on. Here we've got sound, and look at that, the CRT heaters are lit up. Right, so what we need to do now is turn it off and look for another tripler. Right, look at that. I think that's the closest we're going to get. Looks like you have to fit your own anode cap. But look at this. STC, weren't they a division of ITT? So I think that's the closest one we're going to get to the right one, and it's brand new. Right, so I've got the old tripler out. Another thing I've noticed is these 2 screws missing out of that, so somebody's taken them out at one time. I would say that that is the original tripler, because if we turn it around, it's got ITT made in England. If this was a replacement, it'd probably be a cheap copy rather than a genuine part, so I would have thought that's original. But we could probably use this to make another new one. If I cut that case in half, I could replace that with something. There's a sticker on there. What does that say? Oh, it actually says ITT, and it's marked with the number 7807. So I wonder if that's the 7th month of 1978. So yeah, I would say that's the original one. So it needs to come out anyway. And that's also give us an opportunity to get the camera in here now and have a quick look, and give it a little bit of a hoover out down there as well. That's your chopper transformer for the power supply. It's quite dirty in here, look. Yeah, right, okay, let's just give a quick hoover up. Right, so while we've got the tripler out, let's just address this high voltage problem here and here. I bet that diode, if I took it out, I bet I could turn that heatsink so it's facing this way, well away from that connection. Right, so that's the diode out, D24. It's one of the east-west modulator diodes. If you have a look there, you can see how black the print's got. Sorry, how black the board's got. This leaves a very hard life. So while it's out, I might as well just test that. Right, so in order to carry out that modification, I've had to drill another hole in the heatsink because you couldn't just turn it round because of this lip here. There we go, job done. So when we put that back in now, the heatsink is facing the other way, well away from the EHT nipple of the transformer. And there we go, you can see the heatsink was standing up, now it's pointing this way. We've got a good finger of clearance now between that and there. Right, let's get that tripler in then next. Right, so there we go, the new tripler's in. Now I've run into a couple more problems. The lead on this is a bit shorter, so I can't dress the lead in the right place. See that rubber grommet there, that went in there, and it's long enough to reach, but when you tilt the chassis up, obviously that goes down, it stretches this lead. So we're going to have to bring that out somewhere else, but that is not the biggest of problems. I've spotted another problem, and we could have caused some more damage on this by turning it on, and this is one of the problems with using pattern parts. So I managed to modify that so it's away from the EHT nipple, but you see your winding here, you've got the 50 volt peak to peak line pulse. If we come around here, you can see there that this pin is actually touching on a part in the east-west board. So if I move it away, you'll see. But when it's in the right place, it shorts that resistor out there. So I'm going to have a look what that resistor is on the diagram and see what, if anything, we might have damaged. But we're going to have to put, I don't know, perhaps take the wire off there and bend that tag up out of the way to stop it shorting out. So let's just have a quick look at the diagram. Let's pull that out. So what is it there? Resistor, no, it's upside down, that's why I can't read it. Resistor 906 has touched onto that winding. Right, so let's have a look. Resistor 906 is there. So we've touched one of them ends to that 50 volt auxiliary winding. At the worst, we've either damaged that transistor or that diode. I can't see anything else that's going to be wrong. So let's just plug that back in for now and put a piece of insulation under there. Right, so once again I've just slipped a piece of plastic in there. That's just temporary, we'll come up with something after. But that will allow us now to switch it on and see what happens. Right, so I've switched it on already, and guess what? The answer to this is, did it work? No, it didn't. I've turned it on, I can hear the EHT come up, the heaters are lit, but we have no picture. Right, so I don't want to run this for too long in case we damage anything. I've just measured the red, green, blue output here. There's nothing at all there, and it would appear that the supply to the red, green, blue output transistor collector load resistors is missing. So if we have a look over here, it's a 225 volt rail. Just have a look at the source of that. There we go, 225 volt rail. Just a pair of diodes off the line transformer and a smoothing capacitor there. Right, false alarm. It must have been a bad earth on the multimeter, because we do have about the right voltage in the collector, and also the 220 volt rail, or 225 volt rail. That's running fine. So back to the drawing board. Right, so the answer is we don't have any A1 volts, and as it comes from the earthy end of the overwinding and the earthy end of the tripler, I'm wondering if we've got the wrong tripler fitted, and that's why it doesn't work. So guess what, we're back to the drawing board. I did think this was possibly not the right tripler, but I fitted another one and it's absolutely no different. We still have no A1 supply. So back to the drawing board. Right, so I see the problem now. I'm racing ahead of myself here. This is not the right tripler, and I'll tell you for why. Because that is the wire there that carries the G2 A1 supply. I desoldered that, as you can see, and with this tripler in, I measured it and there was no voltage there. But I've fitted another tripler. I've still no picture, but I do have a voltage on this pin now. So let's just have a quick look what it is. Well, meter's overloaded at 1000 volt, so we got more than 1000 volt there now. Right, so let's check the voltage on the A1 control. So we've got 983 going in, and we have coming out 507 volt. So we do have an A1 voltage now, but we still have no picture on the screen. Right, so I've turned this set round towards me. I can see what I was looking from the back and expecting the screen to be lit up in a reflection in the window in front of me. But now I've turned the telly round, I can see what the problem is. Let's just flick it on quick. There, frame collapse. So that's why the picture's been blanked out. If I turn it on and off a couple of times, we might have an east-west fault as well, because we don't have much width. So anyway, we're making progress, and we only have scanning the top half of the picture, so I would imagine there's probably a frame fault as well, maybe even caused by shorting that part on the east-west board. Right, so if we look at the diagram here, it's a discrete frame output stage. We've got a pair of transistors. The first thing we need to do is check the 24 volt supply there. That could be low, the reservoir capacitor could be low, but in view of so 24 volt, in view of the fact that the width is in, the 24 volt supply actually comes from the east-west diode modulator. So I'm going to try these two diodes first. That one is the one I took out and I tested. So so we're going to look at that one next, but that would explain why the width is in as well, and that also supplies 12 volt rail through a pair of series pass transistors. So let's check that diode there. Right, so both them diodes are alright, and we do have a 24 volt supply, so it looks like we've got two different faults. We've got a fault in the frame and a fault in the east-west modulator. Right, so this stage here is your oscillator, this stage here is your output, and they're separated by a 10 microfarad capacitor there. So we need to make a waveform check on the negative of that capacitor first, or the wiper of the height control. Right, so actually I don't need to put the oscilloscope on yet. I was going to measure this capacitor C20, but by visual inspection I can see one of the leads is actually green, so whether it's leaking electrolyte, but we need to change that. C20 10 mic, which is where does I just see it? You can't see very well, but it's there. I'll show you a picture when I get it out. There you go. It's very hard to see, but if I put my finger there, can you see it's got a green leg? That is definitely not right. I will just test it, but I would imagine it's leaking electrolyte and it's probably dried up. So I don't think that's the problem either. I mean, it tests with inspect, that wouldn't stop it working, unless of course it's got a very high leakage. Right, so I've changed that cap. I've just left the legs on so we can take a scope reading, and we do have a frame ramp, so confirmation the problem is in the frame output stage, but we could have an east-west problem as well. Right, so I think we found a possible suspect. If you look at this diode here, it's actually rectifying a line pulse off this transformer, and it's smoothed by that capacitor there, C10. It actually provides a negative rail if you look. Sorry, not C10, C21 10 microfarad. And that's it. Let's press the button. Yeah, open circuit. So that is our prime suspect. £10 microfarad, 160 volts. So what did that do, everybody wants to know? Well, the answer is absolutely nothing. We've got exactly the same problem we had before. So I've done a bit more testing, and it seems like the upper frame output transistor, a tip 33, has an open circuit collector connection. Now it just happens, as it happens, I've got these in stock, so not a problem. But it's in an awkward place to get to. I've cleaned all this flux off here where somebody's been soldering, taking the excess solder off, and it's right down there, that's not the biggest problem. The biggest problem is it's bolted through the back there somewhere, so I might have to take them resistors out to get to it. I've had to take both of them resistors out, but you can see now it's right down there on the back of the heatsink for the line output transistor, and that there is the nut that holds it on. So I'm not sure I'm going to get that nut back on there because there's very little access in there, but that's your transistor there that's going to come out. There we go. I can only just get in there with a screwdriver. Yeah, faulty that. It is the collector connection, the middle one, that's open circuit. Right, so the new transistor's in a bit fiddly, but we got there in the end, and guess what happened? Well, I switched it on and we still no picture. So what I've done is I've increased the anode 1 voltage a little bit, and that has actually brought a picture on the screen. So let's turn on and see what we've got left now. There we've got kind of a raster. It looks like we've still got other issues, but the actual colour of the raster looks very good. The tube looks sharp, and I can see the line, the focusing sharp on them lines as well. So I think what I'm going to do now is just see if we can tune a picture in and see what happens. Right, I can see now why I've had to turn the A1 control up to get any visible picture on the screen, because the beam limiter's stuck on. We've got volume.
Well, every day and night down this strip.
I do have a bit of a picture. The colour control doesn't do anything, but more importantly, if you look at the contrast control, the contrast is fully down, and when I turn it side to side, it makes no difference. So the beam limiter is stuck on. So that, we'll worry about the picture geometry and everything later. We'll just get some sort of picture on it first.
For its waterfront and proximity to beautiful beaches. Despite property prices here going up by 40% over the last 5 years.
But that's where we are so far. So if we take a look at this, the beam limiters here, it's very simple. The emitter of that just connects straight to the contrast control, so that transistor must be hard on, pulling that down to ground through that resistor. I mean, at a push we could just disconnect this line here, but as there's not a lot to it, we might as well just check these two transistors. The other end of course comes from the earthy end of the HT and the G2. That, I think that's the earthy end of the A1 grid 2, and this comes down here, will be to the earthy end down here. So let's just try these transistors first, T1, T2. Right, it's actually very difficult to read things on this board, but I think that's T1, T2 down there. But I see some more capacitors with green legs. So, not the Dubilier one lying down. The three standing up seem to have green legs. So, I think I'm just going to change them before we start looking anywhere else. In fact, you can see on the board there a little bit of a black patch around one of the legs. I'm sure that's electrolyte leakage. So, let's change them first. Well, just as I expected, that's done absolutely nothing, but you can't leave them in leaking electrolyte because you've seen what damage it does to the board here on that other one we changed in the very beginning. Right, so I've confirmed that this transistor in the beam limiter it is stuck hard on, but these two transistors are alright, so we need to trace this back here. And your prime suspect there will be D3, but this isn't particularly easy set to work on, and things aren't where you'd expect them. I mean, that's shown next to these pair of transistors, but if we look at this telly, the pair of transistors are down here, but then D3 is actually right down here somewhere in the line stage. So where did I just see it? Somewhere buried down there anyway, so we're going to get that out next. Right, now I don't know if you can see this, but that's where it is, right down there. So I've desoldered it. Let's pull it out. That one there. And there you go, look at that, it's leaky. So it's only a 1N4148. Let's get one of them in. Right, so I'm expecting that to have cured the beam limiting fault, but I'm sure we're going to have other faults on this telly. Right, so here we go. Let's switch it on.
And ground floor apartment. I think they realise that to get what they really want, they need to up their budget. And I can't wait to see what.
And there we go. We've now got a working contrast control. In fact, we've actually got colour, look.
We've certainly gone on a search, haven't we?
Grayscale's a little bit off, but the picture's sharp, with lots of colour, and now the contrast works.
And the style. You know, you really did want something a lot more modern, clean lines.
So the last fault, the picture geometry. Also, I can see a few striations down this side, whether that's anything to do with the east-west fault. But I think what we're going to do now is whip out the east-west panel.
We are looking for.
But yeah, it's looking really good.
Property 5, and how you felt, and how you're feeling.
Contrast minimum,
I
contrast maximum.
I feel like it was the most amazing property, the way it was decorated.
Right, turn it off. Let's get that east-west board out and have a look at that pot that looks a bit manky. Right, so that's the east-west modulator board. We've got two pots that are sealed, and we've got an open one which looks very, very manky. I don't know if I can put any switch cleaner on just to bring it back to life, but let's just have a quick look on the diagram which of the adjustments that one is. I would imagine it needs changing though, but either way there's not much on there to go wrong, is there? In fact, let's have a look what we've got here. Just 3 transistors. That's your driver, and then you've got pin cushion and width. So I would imagine the one we're looking at is 912. Yeah, that's the one, 912, that one. You can see it's very, very green, that. So there we go, 912 2.2K. Let's just stick a new one in. Right, so I can't find one of these really high quality ones, but I found this one that'll do. Yeah, 2K2. That will do us. Let's put that in, see what happens. Right, so the result is, watch this. I've got my screwdriver in it there.
Property number 1, how are you feeling so far?
Yeah, width out, width in.
But this is not really the location we were looking for. Alright, okay. You're giving it to me straight.
Another good result.
Will you indulge me?
In fact, it's getting near perfect, this. I can just see a couple of striations there, so that'll have to be dealt with. And there's a bit of sibilance on the sound, but I've seen a modification for that in one of them technical sheets. But look at that for a telly. This is like 45 years old.
It's got its own scene going on, so the location is good. But when it comes to the curb appeal, then that's not for me.
Right, I think I'm going to have to come back to this because I've got some other things to do now. And there's still the matter of the on and off switch that's stuck in. But yeah, look at that.
That is not what I want at all. Okay.
Just still needs a quick tweak of the grayscale.
Alright, so it is very old school kind of Spanish flavour. It's 4 bedrooms. Oh, yeah.
Right, I'll stop the video now. We'll come back to it in a bit.
Maybe a little bit. I'll be interested to have a look.
Before we come back to it, I've just put it on the Sky homepage because that shows it up better. You can see the striations there. Just right down there. Right, so the parts I've changed are building up. Let's take a look at the cause of the striations. Right, it's either going to be one of two things. It's either going to be the damping resistor across the line linearity coil there, or it's going to be the line flyback blanking pulse. There's something wrong with that, and that comes through these network of components here applied to the grid. So the easiest place to start will be that resistor there, and for somebody who's, I mean most people know this, but for somebody who's not seen a resistor symbol like that, let me explain. The top of the resistor has two contacts that are sprung together and they're soldered, and what happens is if the resistor overheats, the solder melts and the spring contacts open like that, and that makes the resistor go open circuit. So I would imagine the resistor will be alright. If there is anything wrong, it's probably sprung open because at one time it's had a dry joint on that coil. So let's look out that first, R100. Right, well that's the horizontal linearity coil, L29, so the resistor can't be far away because it's in parallel with it. And there it is, that massive great big resistor standing up there. I'm going to have to desolder it to check it because it's in parallel with a coil which will have a far lower resistance, so we can't test that in circuit. Right, so that's not the problem. The resistor's reading correct, should be 390 ohms. That's well within tolerance. That is not the problem. But before we go looking elsewhere, let's just take a look at this for the younger people who haven't seen one before. This bit here is your spring, and that there is your soldered connection. Let me just warm that up with a soldering iron, I'll show you what happens. I mean, really, this was an ingenious idea. Right, here we go. Let's see if we can get the camera in there. So that's your resistor there. So you get an overload. This gets very, very hot. It heats up that soldered connection there. And as you can see, it just springs open and opens the circuit, switches the current off. So all you've got to do when you see one of these, you know there's been a fault. You don't need, most of the time you wouldn't even need a new resistor. When you fix the fault, you just solder that back together. Absolutely genius. And that's it there, look, that's the resistor reset by just soldering it back up again. Right, so over the tube base next, let's have a look here. So we're going to be testing or looking at that there, which is a safety resistor, and that's highly suspect, having 125 volt on one end. That could have risen in value. So let's take a look at these next. Right, well actually we seem to have a slightly different arrangement on my tube base, because that's got one diode in and my set's got two in series. But I'll tell you what the problem is. We're working from the CVC20-2 manual, and the set is actually a CVC20-3. Anyway, it doesn't matter because this is close enough to see what the problem is. And just like I suspected, R602 22K, it's completely open circuit. Let's put it on there so you can see it. No, we don't have very good light. Actually, that's better. And you can see it's actually got quite hot because the 22K red orange, and the orange band has actually turned like a brownie colour, so you could mistake that for 220 ohms, but the manual says it's 22K. There we go. I've just got it on a couple of crocodile clips so I can do it hands free, but if you look at that, completely open circuit. So let's just pop a new one of them in. Just as a side note, if you remember that diode that was faulty in the beam current limiter, if you look at the original manual I've got here and we turn to the back page, I'd actually had that fault 40 odd years ago, so must have been common back then as well. Right, so that resistor obviously leads a very hard life. We're going to put the same type of resistor in, which I will have somewhere here. Right, see the difference in colour now between the old one and the new one. Right, so changing that resistor has made it a lot better but still not perfect. You can see it's still there if we turn the contrast down.
The labour movement and of this house, a man who fought for working class ambition.
So, time to look
As one of the key architects,
somewhere else.
John achieved that rare.
Right, so I've still not found the cause yet, but I do see something else I don't like down there. If I zoom in with a camera, you see that little capacitor there? There's 3 wire wounds near it, and you see how hot the board's gone. That capacitor will almost certainly be open circuit. So I'm just going to change that first. Right, well, as you can see, it's not actually open circuit, but it does have quite a high impedance. So I don't think that'll cure the fault. We're going to change that anyway. And just another small thing I should point out here regards these earths and these tabs sticking out. Now, if you look at that, you'll find that most of these, I don't know if it shows up on the camera, but most of these are dry jointed. Now, in a lot of cases, it doesn't matter. If we look at that one, it doesn't actually connect to anything, so it doesn't really matter. But if we move over to this one here, that, if you trace that down, that actually carries the earth from Capacitor C28. So a dry joint on there would cause you a problem. And now these are all scattered around the board. Some matter, some don't. It's just easy to resolder the whole lot of them rather than take any chances. Yeah, you see that one there, that doesn't actually matter, but you can see it's got a big crack in the solder where the metal frameworks broke away from the PCB. Now, I'm actually just doing these with a paste soldering station set to 415 degrees. That's plenty hot enough. But back in the 1980s, I was using this to resolder them big heavy duty connections. The Weller soldering gun, but with new technology, new advances in soldering irons now, I mean, stuff like this is it's pretty obsolete really. You never use this anymore now. Right, so at this point I've still not fixed this annoying little picture fault, but I think for now let's just turn attention to the on and off switch, which is stuck in the on position. Right, so that's the board out. You can see there the on and off switch. I would imagine the contacts are welded together because these switches always were trouble years ago. And if you look there, we've got the famous filter capacitor. Now this is actually a later one. It's a grey one. If you remember in the ITT CVC9, and before that they had a yellow one. That were always burning up. Well, the yellow one was rated for 220 volt. These are actually rated for 250 volt. But actually, if you look at this ITT technical bulletin, although we knew the failure was because it was 220 volt, ITT say here, we are of the opinion that the component aging together with dust and grease deposits which build up over the years adds to the failure. How can dust and grease affect a capacitor that's 30 volts underrated? But anyway, there you go. Right, so the next thing is try and look for an on and off switch. Well, I've got hundreds of them. Whether I've got the right one, that is anybody's guess. But we'll certainly have a good look. Right, well that's it out. So we might as well clean these controls now with a bit of switch cleaner. You don't want to do that when it's in, because Servisolol, even though it says it doesn't attack plastic, it does. And if you spray it everywhere, you'll probably end up with all these posts all falling to bits. So I can clean them now it's out. You might as well have a look at the tuner unit while you're there. That's how they get the different resistance, by tapering the actual carbon track. But that's in really good condition, which is just as well, because you never find a replacement for that now. But that's the switch there. I can't make my mind up whether it's had a switch before or it's just been getting hot. Anyway, let's get it out and see if I can find something for it. Right, so I've gone through 3 boxes of switches. I cannot find the right one. I think the nearest one I can find is this one. And what's that for? Doesn't actually say. But although it looks totally different, it's the nearest pattern. So let's get it out the bag. Right, I think that's the one actually. If anybody's got an old SCME catalogue to look it up, it's SW669. But it matches exactly the same pin spacing. One peculiar thing about this though, if you look at the button, it's kind of offset to one side. But anyway, I'm sure that will go in. Right, now unfortunately the switch I've took out didn't work, but I've left this switch out for safety reasons, because if you look at there, I clip my meter one to the live and one to the neutral, and we've actually got leakage within that switch, so it's probably all full of carbon anyway from constant switching on and off, flashing over. So just for safety I've left that out and I've linked it over. Right, so I think under the circumstances, because I haven't got a switch and it could take a long time to get one, and I've still got minor issues with this TV. I've still got these striations down one side, which I've not managed to find the cause of yet. I've still got the sibilance on the sound, but I'm thinking because of the I need to find a switch, and I don't know how long that'll be. I don't really want this video on my camera for weeks and weeks, so I think what I'm going to do is I'm going to close the video now. I've achieved what I set out to do. I've got a picture on the TV, that's on the colour bars. Let me just turn it back from sky and let's put a picture on. The black band that you can see on the screen, that is obviously coming from a camera. I don't have that on the telly. Oh, wrong. I thought that was a volume. Wrong one.
Out. Delivered in time for Christmas. The Furniture Village Black Friday sale. It ends soon.
The G-Tech Black Friday sale is back, with up to 50% off across our best-selling garden.
But yeah, look at that for a picture. What an amazing set this is, considering it was made in, what do we say, 1976, 1977?
I wondered if I could interest you in a...
Sorry, we're on holiday, mate.
Oh, just before we wrap the video, let me show you another interesting thing I found. It takes an awful long time for the tube to warm up and come up to full emission. But if we have a look at it here, it also takes a long time for the tube to cool down. So if I pull the plug here, look how long it's taking for the tube to cool, for the heaters to cool down. That's probably a good 20 seconds before the heaters actually cool down after you've unplugged it. Anyway, I think let's wrap the video there. There's more work to do on this. I've got to find a switch for it. But before we close the video, let's just have a look at the component list I've changed. So there you go. You've got your line transformer, your triplet, your frame output transistor, your HT rail rectifier, a sprinkling of capacitors. Some were low, some were leaking. A resistor I changed, which was out of spec, but it made no difference. And a potentiometer on the east-west board. But there you go, look at that, what a telly, what a picture on that. And it's been a real trip down memory lane for me repairing this, because it's a long time since I've ever seen one of these.
150, 150.
But look at that, you cannot complain at that picture, even though it's quite slow for the CRT to warm up. So let's just kill the power here, and then we can take one final look. The ITT CVC20. There you go, guys and girls. Alright then, many thanks for watching my video, and I'll catch you in the next one. Goodbye.